So let's have the eSolution now for problem 8 in Segel's biochemical calculation. The problem 8 in page 320. Problem number 8, page 320. And this problem states that an enzyme with a Km of 310 to the power of -4. All right, so let's take note of that, very important. 310 to the power -4 molar was assayed at the initial substrate concentration of 10 to the power of -6 molar. So the substrate initially was 1 micromolar, 10 to the power of -6 molar. And it says that by 1 minute, by the time of 1 minute, there was already 5% consumption. 5% of the substrate was used, was consumed. All right, so first of all, before even answer the question, because the first question is what percent of the substrate will be utilized by 5 minutes? Let's see what we have here. We have this reaction with a Km of 10 to the power -4, and you are say that at the 10 to -6. So what can we tell about this? This is a situation here where we have this reaction, right? We always have to remember this. And we are, this is the Km, and we are below the Km, way below the Km. So you are in the, what we call the first order region of that graph, right? So because the concentration of S is much smaller than Km, this would be a case of a first order reaction. And for the first order reaction, we know that the relationship of the starting material and at any point is going to be related by the initial concentration E minus Kt. Correct? So that's what we have. So we know that we had 5% consumption at a certain particular period of time, and we then have, we don't have it, we have acid initial, we don't have it how much, but we know that's 5%, and now we have T, so we can calculate K. So basically what Segel is doing here is try to give you K indirectly. So let's calculate K. How do you do that? So after 5% was consumed, so what's the amount of that substrate at that particular time? 5% was consumed. So we only have 95%, right? Or we have 0.95 S0. Whatever, we don't even need to plug in the S0. And initial S0 minus K times T, it is going to be 1 minute here, right? So this simplified here. How you solve that problem now? We have 0.5 at one side of the equation, the other side of the equation, e to the power of -k. So the best way to do that is to take the natural log of both sides of the equation. So the log of 0.95, natural log, okay? So we want to make sure that you get the natural log, which is 0.0, it's negative 0.0513. And the log of this other one in here is going to be -k, right? Therefore, we found what Segel want to give us, the K, which is 0.0513. And what will be the unit for this K in this case here? So this K is going to be minutes -1, because we are talking about 1 minute in here. Okay, so that the unit of time was 1 minute. The question is, what's the percent of the substrate will be utilized by 5 minutes? Okay, by 5 minutes. So now substrate at 5 minutes is going to be substrate initial times E minus 0.0513, And because it's 5 minutes, we have to multiply this thing here by 5, right? So the substrate at 5 minutes is going to be equal let's see what this number here is going to give us in the calculator. It's going to be 0.77 SC0. Okay, so the question is that what percent of the substrate will be utilized? We have 77% left. So how much was utilized? It was used 100 minus 77% that is still there, right? So this is going to give us 23%. After 5 minutes, 23% was used, right? Now the question B is that if the initial substrate concentration were 8 10 to the power of negative 7 molar, what the percentage of the substrate will be utilized by 5 minutes? A very interesting question. Trick 1, try to get you in trouble. The questions again, this is letter B. It says that if the initial concentration of the substrate were 8 10 to the power of negative 7 molar, at 5 minutes, what will be the percent used? So, do you see that we solve this problem here even without using the concentration, because we are looking at the percent? So it doesn't matter how much the concentration was initially, as long as it is still in the first order reaction, right? So if this first order reaction doesn't matter, and the concentration is relevant in here, so that what it was as a percent is the same. It's going to be the same, 23%. Same 23%. All right? And the letter C for this problem, calculate Vmax. Calculate Vmax. So let's calculate Vmax now. Vmax, how much is that? So we know that this, since this is a first order reaction, we know that K equals Vmax over Km, right? And from here, we can calculate Vmax. That's equal K times Km, right? So Vmax then is going to be equal K that was already calculated before. It was 0.0513. And what was the Km for this reaction? Was 3 10 to the power of negative 4, right? So this is going to give us 1.54 10 to the power of negative 5 molar per minute. Molar per minute. That's the Vmax, okay? Letter D, ask it to add the 8 10 to the power of negative 7. How long will it take for 50% of the substrate to be utilized? Okay, so question now. Question D. More space for us here. Question D. Concentration of the substrate being 8 10 to minus 7 molar. What would be the time for this thing to become 50%? 50% is 10 times half, right? The half time. And then we have a direct relationship for half time, which is 0.693 over K. Right? So we don't even need the concentration here. So we have 0.693 divided by K, which is 0.0513. 13.5, and this is minutes, right? Because we are working unit of minutes. So that will be the answer. Very easy for question D. Okay, so what was the relevance of the concentration given? To assure you that we're still working the same first ratio order, right? So we are working here at a number that is much smaller than the Km, right? So this was the only reason to give this concentration. And again, at the 10 to minus 6 molar, how long would it take for 70% of the substrate to be utilized? Now, in part E, the concentration of S, the substrate, is 10 to minus 6 molar, and for the time that 7% of the substrate to be used, or only 20%, 5% is going to be left, right? Because remember that formula that we have, S equals S0 e to the power of negative kT. This is the concentration of substrate existing, right? Not what was used. Then we are going now to plug in these numbers and utilize the same equation that I'm talking about. Minus kT. All right, so we have now only 25%, 0.25 SC, 0, equals SC, 0, E, and the K we already know, 0.0513, and what we need to know now is T, right? We need to determine T from here, all right? So this will be easy, simplify. The best way to do that is take the log of this side and log of the other side, so that it becomes log of 0.25 equals natural log of e to the power of minus 0.0513 times t. So from here, we can say that what's this log in here, 0.25 to make sure. It's negative 139. Negative 139 equals 0.0513 times t. So from here, t is going to be equals 27 minutes. That's the time that we will use to consume. So 75% is going to be used. 50% to use, 13.5. 75% to use, 27 minutes. All right, so that's the solution for problem A.